It's low. Internet is low.
It's too low.
It's too low. No, because we have to connect this PC because there is Jitsi, there is streaming. This is an application for the streaming. For online. Yeah.
Non riesce a fregare no, the flash memory. Come te l'ha passata lei prima? Ah, quella?
Sì, questa è la mia.
Sì,
sì. Però questa seconda devo gentilmente fare una... Giuliano, giusto? Sì, Giuliano. Ok, perfetto. Perché sto pronto a scaricare la tua, però a questo punto provo a scaricare.
Che faccio? Le faccio mandare a lei?
Sì.
So, io...
Okay.
Tu... Rossella?
Ci stiamo prendendo.
Now? You mean now?
No, you know. Because you pass by USB.
O?
Grazie mille. Ma qui è terribile.
No, guarda,
Perché poi ieri ero in un'altra stanza almeno funzionava il computer, questo non funzionava.
Ma conoscete il cielo? No. Se c'è bisogno posso dare come vuoi tu.
Io sono
Ne siete due.
Ma
Perché questo è la seconda volta che fanno. Quelli di prima, che hanno provato tipo sabato, venerdì, erano ancora peggio. Eppure sono qui,
Ma così stanno... È strano. Sono collegato. sbagliato?
No.
È andata?
Sì, però loro non mi hanno dato.
Oh, thank you.
You have the shape?
No.
no.
Who is this? It's Michaela.
no,
it's okay. I will do. Can you share the session?
I can show, but I have a presentation in another.
Oh, sono.
Ma comunque ha detto che lui può fare scelte, nel momento in cui
Sì, no, dobbiamo, non è che ci conosciamo. Bene ti mando in io, no problem.
Non me l'hanno dato.
Grazie mille.
Grazie Fabio,
Grazie, penso tu.
Me la
Sì.
possono inviare se...
Grazie. Yeah, please change the email because I can't manage to access my
Yes.
bravo.
Non vedo niente qua.
No, no, gli altri li ho già qui.
Ok. Ma non sono io questo però.
No. Adesso. Ok. Il passaggio.
So the first one is here. Vanessa, Matteo,
Yeah, fine.
Herbert, Rossella, and Belisa. Okay.
Un secondo che carico le nostre presentazioni, come le vedete?
Certo.
9:20.
Stiamo provando a recuperare un pochino, ci diciamo. Non si può fare una enorme.
Che università ti dà?
Bambidetto.
Ah,
Era la seconda volta della
Di là.
Tu dove ti trovi?
Io no. Io dell'Ateneo Lucano.
Di Francia ci sta pure qualcosa.
No, sì, abbiamo il campus e ora c'è il campus. In realtà ora è arrivato medicina da 4 anni e quindi anche ingegneria a volta
Ingegneria
completata. Noi facciamo meccanica e poi c'è civile ambientale. Un civile ambientale. Ingegnere ambientale.
Ho fatto idraulica.
Ho fatto idraulica, sì.
Come stai facendo? Che devo fare?
Ora sto facendo il dottorato in no, prendo credo alla Lussemburgo, poi torno quando
Yeah, no, no, thank you.
Share the screen, please.
Which?
Share the screen.
Ah, quindi,
Sì.
Now everything's working. Sorry.
scherzando, giusto per
No, no,
scherzare
ma
un po'.
certo, ragazzi.
Okay, this is the aim of this two-dimensional study, that it is very simple with respect to the complexity of the problems. The main is to compare the performance and accuracy of two different open source solvers. Because in the past we have done a lot of work on fluent architecture. And then we are testing open source solvers, specifically one solver that is very famous is OpenFOAM, in particular solver in toolkit OpenFOAM, and another one that is recently developed code by some colleagues in France. It is called EcoGen. So we can validate these codes with respect to experiment, and of course to provide guidelines for next future three-dimensional simulations. This is a sketch of our computational domain. So we have a tandem shock front that impacts tandem. We have also simulation to one droplet, two droplet equal, so a tandem, and the tandem has two different disposals. It can be in the stringwise disposition or in the sparwise. So this, the diameter of the droplet is exactly the same as for the experiment of Graph and Kaplan. So the solvers are both based on the finite volume meters. They solve the compressible Navier-Stokes equations for two-phase flow. So they are based on the volume of fluid method that treats the mixing between two fluids as one fluid that has properties average between the two different phases. There are some, of course, some differences between the two approaches. EcoGen it was developed by Maya and co-authors, and the particular solver in the open solver we used was developed by Kaposhi et al. And we have also published recently a paper on the use of the open form solver. So can go on. These are the EcoGen equations. Practically, it solves simultaneously the two phases and also the mixed fluid. Anyway, we can skip this. The open form set is slightly simpler. Okay, what about the thermodynamic closure? As in any compressible flow solver, we need to add equations for the thermodynamic state, and we use here for the air, we use the model of ideal gas, but for the liquid, we use two different models suggested by the authors of the solvers. Okay, so what about the mesh? The mesh the meshing strategy is different for the two solvers. EcoGen has got an adaptive mesh refinement strategy. So the maximum resolution that here is 128 cells per diameter is only at the interface between liquid and air. OpenFOAM, the particular solver will, by precaution, has not this feature, so we used a uniform mesh with the same spatial resolution. Okay, as a preliminary step, we solved the flow in the shock tube, so to simulate the traveling shock without the presence of any droplet. And here you can see a grid convergent analysis that demonstrates that we are able to reproduce ideal profiles of different temperature density and so on. So these pictures are very interesting because we are directly comparing experimental images, that is the black, where the droplet is black, and the results of our simulation. And it appears that we are able to reproduce, at least qualitatively, the deforming shape of the droplet. These are examples of density field and vorticity contours. So initially, as I told you, we are simulating practically the flow over an obstacle that is at the same time drifting and deforming. These are contour maps for the single droplet simulation. Here you can see the vorticity on the top panel and the velocity on the bottom one. And you can see the front, the shock front that is traveling, and the formation of the shedding here, the wake, and at the same time you can see how the droplet is deforming and finally is becoming like a sort of a piece. Of course, these are two-dimensional simulations. Okay, and this is another way of illustrating the results that is similar to what do the experimentalists. They see they analyzed the density gradient field, and here you can see the numerical shading. So these are numerical results. And once again, as you can see, here you can see the droplet, the first droplet and the second one. This is the shock traveling, this is the reflected wave. So it is a very difficult structure, but numerics is able to reproduce, at least qualitatively, for now. This is the velocity field for the tandem in streamwise disposition. As you can see here in the bottom, you can see the Schlieren, the phi is the Schlieren, and you can see here the ligaments of the liquids that are forming from the parent droplets. These are further instance. Okay. And here we can see the difference between the two solvers. Because if we look at some details of the interface, we can see that Ecogen shows a smoother interface with respect to OpenFOAM that is able to capture some instabilities of the interface. So one can argue that these two solvers have different numerical viscosity. So probably Ecogen is more numerically viscous with respect to OpenFOAM. And here later on, these differences become also greater, and you can see also the different inclination of the ligaments. And I have to say that the second one, so the inclination provided by OpenFOAM is more likely, is better with respect to, when compared with respect to the So what about the quantitative analysis? And so as it is typical in the scientific literature, we can introduce different measures. For example, we can talk about the leading edge drift, delta x. We can measure the extent of the droplet in the streamwise position, streamwise direction, and we can compare for the different sources. Typically, time is non-dimensionalized this way. U2 is the post-shock velocity, D is the diameter, and T0 is the time where the shock front impacts the best droplet. And looking at these quantitative results and making a comparison with respect to experimental data, we see that in this case, ecogen seems, for the front column, seems that ecogen is more able to provide the data that match better with the experiments. But anyway, if you see the rear column, both simulations are on the border of the experimental uncertainty. So probably the mesh in the weight of the first column should be increased, and probably different models should be taken into account. If you look at the deformation, so the extent in the streamwise direction, and make the same comparison with the experiments, both solvers are doing a good job. So for the real column, there are anyway some differences. Okay, just a spot because we don't have time. This is the span-wide disposition, and initially flow is practically at a symmetry, and but in the later on, the velocity will show some losses. This is a very complicated. This is numerical shaping. So these are the results of our simulations, and we are still evaluating the possibilities in this area. What about the computational time? OpenFOAM for the same, exactly the same case, but I'm sorry, on two different machines. Anyway, we have compared here the computational complexity using core giga-hour. So it is however possible to make a comparison between them, and we can say that ecogen is almost 10 times more efficient than OpenFOAM, but as I told you, it has more numerical diffusion. So one must take care analyzing the results. So the conclusions. The AMR is adaptive meshing refinement was crucial, and also I didn't tell you about the non-reflective boundary conditions because the domain is small respect to the complex flow field. So it is very important to use this kind of strategy for the numerical boundary conditions. And the perspective, of course, are two. The first one is to reproduce spherical droplets. In the past, we already did the work with commercial code, but now we are extending using open source ones. And since this is turbulent flows, practically we are solving without any model for the turbulent fluctuations still. But in the future, we want to introduce also a model for the subgrid scale structures. Okay, thank you. Any questions?
Any questions?
Because the chairman is sorry.
Now I have a question.
Okay, thank you.
Here you have to compare the two open source software packages regarding their position and the running time and all that. But you also mentioned that in the past, you have previously worked with some commercial software systems.
Yeah.
Have you compared these open source systems with the commercial ones? How do they?
We already demonstrated in the past that commercial solvers, specifically ANSYS is able to use this kind of technology. But the problem is that it is a black box. So our task, is to analyze the solvers and to see the effect of numerical disposal. And we cannot do this with commercial. So from one point, we know that the commercial code was working pretty well. Of course, as any other numerical approach. But the problem is with commercial code that we cannot go far. Okay, the problem is very hard to be treated. So we have to know about practically the numerical viscosity that the code is introducing. And meanwhile, my PhD student, that is Patela, is working with French people that developing the code, and we are working on the structure to see how it works. Thank you.
Thank you. Any more questions?
Okay, so now on. Okay, so we can skip to the next presenter. Vanessa Landero. Okay. Last. Okay. Study cases on initial solution searching for taboo search and threshold accepting algorithms on bin pegging problem. Okay. And Vanessa is presented. Right.
Start with my presentation. The content are introduction, a general review, after a framework, experimental, after comparison and discussion result, and finally conclusion and future report. Introduction. The scientific community several areas of knowledge
Only right and left buttons.
There's no light?
Okay, just these two. Okay. Left and right.
And there is no
Light.
I don't know. I will not read.
Well, the scientific community several areas of knowledge like computational complexity theory, graph theory, data mining, artificial intelligence, machine learning, combinatorial optimization, operation research, use algorithms for solving problems such as decision, optimization, forecasting, classification. These algorithms are approximation algorithms, and the scientific community has identified four principal parts from the logical internal structure of the solution algorithm. They, for developing improvements into them and giving the best solution. These parts are First, initial solution generating and parameter tuning, like temperature, threshold algorithm. Another part is the neighbor solution searching, and the other part is algorithm execution stopping. Um, Review specialized literature. These four parts, algorithm logical extension, the related works, the majority related works have developed improvements in these algorithms, for special threshold algorithm and taboo search algorithm. And in this part, some related words in this part, but and we we think that the most important part is are the two, the initial solution and searching methodology, because in this part there is no improvement in the algorithm performance. Framework. For the nomenclature, P, there is no like sorry. P accept instances of problem domain P, the space for analysis. In this case, the problem is one-dimensional vector problem, and it contains 324 problem instances, which were selected randomly from repositories and library and operational research library. Set A, a set of n algorithms, in this case, taboo search and threshold accepting algorithm. Why the performance space, it represents the mapping of each algorithm to a set of performance metrics, in this case, quality and time. Variance and scenarios. In scenario one, we have for two algorithms, threshold accepting and taboo search, and this configuration for the methodology to initial solution, random, deterministic, but methodology for neighborhood use one method only, and the two scenarios is the same, but the difference is the neighborhood methodology use several methods. It is the subcode for generating a random initial solution. It is subcode for generating a deterministic initial solution. Subcode for generating a neighbor solution with one method, and the same for the difference with several methods. Characterizing algorithm performance and studies cases. Performance metrics, quality, and time. Time is the feasible solution plus infeasible solution. The quality is the ratio between the best solution of an algorithm, final number of containers, and theoretical solution is equal to sum of object sizes divided by container capacity, C. The lower the value, the better the quality. Set Y for both algorithms, for variant algorithms or algorithms quality time, C for all problem instances, 224 instances problem. Scope of algorithm, we compare quality for the first time, and the second time the time in this case. And we check the total scope for each algorithm and we detect domination region of algorithm using this metric. Um, Study cases. We have two study cases for each scenario for two algorithms, physical asserting algorithm and research algorithm, variance, we check the scope total and we identify domination regions. Comparison discussion results. In the first scenario, we analyze in graphics in initial solution methodology on a searching with one method. For the threshold accepting algorithm, we identify this, this situation when the algorithm uses deterministic initial solution finish faster. Yes. In a graphic and performance, in a graphic quality performance, there is no difference between two variants of just for asserting. In case of study, two taboo search algorithm, another algorithm, variants of this algorithm, we detect the same situation. The algorithm that use deterministic initial solution finish faster than another algorithm. Quality performance, there is no difference. Scenario 2, initial solution methodology on a searching with several methods. For the threshold accepting case of study 3, we don't detect or we don't find some difference in the same situation is for the taboo search algorithm in the scenario 2. Sorry, but an error. Initial solution methodology on a searching with several methods. We perform statistical results. We identify the domination region, statistical result, and some observation. The results of the statistical test indicated that there is a significant differences between solution qualities and times. The null hypothesis is rejected in all studies cases from two scenarios. So we develop the scatter plots and we detect that for the two scenarios, the scenario 1, we analyze these graphics, but identify that for the threshold accepting algorithm and the taboo search algorithm, we observe that deterministic methodology for generating an initial solution is the best scenario to perform the algorithms because both finish faster than another that when the initial solution is generating only with a random methodology. In the scenario 2, there is no difference. Conclusion, an initial solution generated by deterministic methodology, either for threshold accepting algorithm or taboo search algorithm, is adjusted better when convinced neighbor solutions are generated using a method for switching into the problem space. It is to say, a good initial seed could direct to a searching without intensify it. the source code in the program, and finish in much less time with solution and in situation of worse quality, but with a minimal difference, where the time is more important in a rare situation than this minimal difference. Um, Continuing opening the black box of algorithms, logic, and internal structure, it will be interesting to perform analysis on initial solution methodology in conjunction with searching methodology for other problems and approximation algorithms for genetic algorithms, algorithm and economy of ants algorithm. And the result could give formal guidelines in the development of self-adapting algorithms that do not go before you give the best solution to complex problems depending on the specific needs in various real-life situations.
Thank you. Thank you, Marina.
Some questions?
Any questions for Marina? No? Just a very general one. You are talking about algorithms for general problems and complex problems, I suppose. Can you just make an example for us? I'm not working in this field. One problem, one mathematical problem you have in mind, this problem.
Okay, problems like decisions, when you have a process and you need to some kind of situation, give an answer to yes or no, is a problem of decision. A problem of optimization is when we have some combinatorial variables and with several values, and we need to find the best configuration for these values to these variables and for give the best solution.
Okay, so an optimization.
I can give you a more concrete example if you want.
Later. Thank you. So we can go to the next speaker. Thank you, Vanessa. Okay. So the next one is Anna Perez-Lopez. I hope there will be no problem with the presentation.
Let's see.
Let me check. Okay. This one. Mouse is not working.
Okay, could we close this panel here? Here?
This is Turkish language, this one?
No. To close, wait a minute.